Hello, this is Elaine Roddy with the Ontario Ministry of Agriculture, Food and Rural Affairs in Ridgetown. This is part 2 of the Cucurbit IPM training workshop. And in this part of the training, I'm going to focus on the wilts, which are a number of different pathogens that cause wilting symptoms in cucurbit crops. So I'm going to be looking at bacterial wilt, fusarium wilt, and then Phytophthora, which is often called Phytophthora blight or Phytophthora crown rot. Bacterial wilt is obviously it's a bacterial disease that causes wilting, and it is transmitted by insects, namely the cucumber beetle. And what happens is that the bacteria overwinter in the gut of the beetle, and as they feed and they defecate, the feces is going to mix with the natural moisture on the leaf, and it's going to enter the cut area where the beetle has been feeding, and the bacteria are going to colonize the vascular tissue of that plant. And so what we often see is that the primary wilt will start a little bit further back on the vine where the beetles were feeding, and then it will move backwards towards the crown. And you'll see that entire vine start to collapse and turn an olive gray to fully necrotic. And you can see a good example of that here. We've got the wilted leaves on several different runners, and then the vine itself here has gone necrotic, and it's moving back towards the vine and then also out towards the tip. And eventually this entire plant will die. Compared to some of the other wilt diseases that we see, this one is very random in nature. It just occurs where those cucumber beetles that were infected with the bacteria feed on the plants. So it could be surrounded by perfectly healthy plants on the other side, but then another dead one further back, like we're seeing in the top left-hand corner of this picture. So very random in distribution. There's another close-up, and that just shows you the olive green coloring that you see, and then a very crispy necrotic dieback taking out the whole plant. So it's transmitted by the cucumber beetles, and the susceptibility will vary by crop and species. So cucumbers and melons are the most susceptible. And then the pumpkins and the squash are less susceptible to the bacterial wilt, but they're often more attractive to the cucumber beetle itself. So there's a bit of a trade-off there between how attractive the crop is and how susceptible the species is as to the level of damage that we see in the field. So the next wilt disease is quite a common one, especially where cucurbits have been grown heavily in rotation, where you get a number of years of multiple crops of cucurbits, or just a short, maybe 1 year break in between cucurbit crops. And the symptoms are going to vary based on the type of cucurbit that you're growing. Sometimes what you'll see is the dieback of the seedlings soon after they're transplanted or direct seeded, and then it will take out the entire plant and that plant will die. Or what can happen is that you can have some early infections that occur during cooler, wet spring weather. And those infections maintain fairly latent until the crop reaches kind of peak capacity mode, when it's got a full set of fruit on it and it needs the maximum amount of water and nutrients that can be taken up. Only the roots have been compromised by the fusarium fungi growing within the vascular tissue, and it just doesn't have the wherewithal to move the nutrients and the water within the plant. And then you start to see the leaves die back. And in the case of this melon crop, they turn almost a bright yellow and then very quickly collapse and die. And you can see here that I've lost a lot of my healthy green material. It is chlorotic, turning necrotic, and these fruit are now exposed. They've reached a very nice size, but there's not the plant green material photosynthates there to supply the sugars that it needs to really ripen off. And so these will be, a lower quality fruit as a result, because they're not going to be as sweet, and they're also going to die back a lot quicker because they didn't truly finish ripening on the vine. This is a cucumber field, and it's fairly widespread here. You can see it throughout. It was a fairly short rotation. And in this case, they didn't go the bright yellow that the cantaloupe did. They've turned very crispy and necrotic, really widespread across the field. You can see a bit of a gummy exudate. There's another disease that I'll talk about later called gummy stem blight. It also produces a gummy exudate. So just because you see that gumminess, it's not a great way to determine which crop it is, but you can see the damage to the crown itself. And if we look at the lateral section of the stem, on the left side here, I've got a very healthy plant. The vascular tissue is green and white, and it looks really good. And on the right-hand side here, you can see where that vascular tissue has been colonized by the fusarium fungi, and they've clogged that tissue, and you're not getting photosynthates down to the roots. You're not getting nutrients and water up to the leaves. Fusarium can also infect the fruit themselves, and it can do so on the lower surface where it's touching the ground and maybe a little bit wetter. And then sometimes what we can see is it will go in through that blossom and scar, especially in cantaloupe, where that blossom scar is very corky and it's often got cracks in it. So under humid conditions where the fusarium fungi are present, it can colonize inside the fruit without actually doing any damage to the outer rind. And from a quality standpoint, that's really concerning because you don't want to be selling fruit that have fungal growths inside them. I'm just going back to fusarium, and really with all of these wilt diseases, I'm showing them to you from a diagnostic standpoint so that you can recognize them in the field. Once established, there is very little, if nothing, that can be done to control them. So for the bacterial wilt, the primary method of control is controlling those cucumber beetles so that they don't spread the disease. For fusarium, and then for Phytophthora coming up, the primary method of control is going to be crop rotation so that we don't have the spores in the soil available to infect the roots of the plant and spread into the crown. So Phytophthora also causes wilting. It's got several different phases. It's got what they call the blight phase, where it takes out the leaves and causes massive amounts of wilting. It's got a crown rot where it takes out the center of the crown. And then it's also got fruit rot. And you can see all of those fields and all of those symptoms in this field at the same time, or different varieties might exhibit some of those symptoms more than others. It's really going to depend on the crop and the variety and the environmental conditions. So here the crop has gone off color. It's wilting, and I'm seeing this yellowing to necrosis, particularly on the edges of the leaves, but really all over the place. And you can see some of the entire crowns have started to die back. Phytophthora is a relatively new disease in Ontario. It was first identified in 1994, and we really didn't see much of it. And through much of the early 2000s, where states to the south of us, like Michigan and New York, their growers were really, really struggling with Phytophthora, and they had much higher levels. They were not having adequate controls through fungicide programs. It was a really big challenge for them. And I think we tended to pat ourselves on the back and say, oh, well, we don't really have it here. But a lot of it is to do with rotation. And as rotations have tightened, where growers are now, larger operations, limited land base on some of those operations, the temptation is strong to put cucurbits in the rotation more frequently. And so where we recommend a 3 to 4 year rotation, where that gets tightened and it's maybe only 1 or 2 years between cucurbit crops, that's where we're really starting to see the Phytophthora move in and become more prevalent. So you can see over the course of time, it's gone from very limited number of submissions into the pest diagnostic clinic to starting to see more activity. 2013 was probably our very first big Phytophthora year, and that number looks low, but we saw a lot of Phytophthora in the field that year. A lot of cucumber growers were heavily hit by it. And then in 2019. And then again, last year, we don't have the numbers for it, but last year, 2021, huge amounts of Phytophthora in all of the different crops, but particularly into the pumpkins and squash. We were seeing it last year. So this is the crown rot phase, and you can see it's taken out the entire crown there, and you've got the plants initially wilted and then they just turn necrotic. And the overall yellowing of the crop there. This was taken the first little bit of July. This should have been dark, vibrant green, actively growing. And instead, those plants were going downhill really fast. Sometimes growers call it going backwards. They don't actually go backwards, but they don't go forwards. So it looks like they're going backwards. And there's a close-up of the crown itself. There's no crown material left. It is completely died back, blighted off. And these are the fruit rots here. And the description of the fruit rot is that it's like someone takes powdered sugar and has sprinkled it on the fruit. And the zucchini, it's completely covered that fruit. Whereas with the pumpkin here, you've got more of a circular lesion that you see. There was one initial point of infection in the center of that lesion, and then the infection spread out from there, but still that characteristic powdered sugar look. We've got it in the cucumbers there. And then another way that it can enter the plant is through the actual stem. So it moves in the vascular tissue from the stem to the fruit. And then we see that fruit rot progressively moving back through that fruit. And another close-up of the stem lesions, taking out the stem. And this can completely wipe out a cucurbit crop in really just a matter of days. It goes from looking very vibrant and healthy to having huge numbers of rots throughout. And once it's present, it's really hard to manage that, not just this year, but moving forward into the future crops, because similar to downy mildew, it's a water mold. And it has these very long-lived spores, these oospores that can live in the soil. They've got thick cell walls and they can live in the soil for 10 years or more. So the things I want you to know is the longevity in the soil. So even low levels of infection this year can come back several years from now when we get a wet growing season and the soil moisture level is adequate for those oospores to germinate. And then we start to run into problems, which is why we want to have as long a rotation as possible. 10 years isn't feasible, but 1 or 2 years just isn't long enough. As a water mold, it thrives in wet conditions. So it's got spores that can swim in the soil water and other spores that can survive in irrigation water. So if you've got a field that is draining into another field, it can be swimming in that soil water. And I've even seen it last year where the field they had the pumpkins in was new to pumpkins. They'd never grown pumpkins there before, but they had had Phytophthora in the upslope field a few years previously. And so we figured that it just moved in that soil water from the upper slope to the lower slope, carrying the Phytophthora with it, infecting a crop, even though it was grown on virgin ground. And then what they've also seen in Michigan is where you've got surface water draining into creeks, those oospores are surviving in the irrigation water. And then if growers are pumping that creek water onto their crop, they're effectively inoculating it with the Phytophthora spores. So avoidance and exclusion is your best defense. Rotation, your field selection. In peppers, there is some varietal tolerance. We haven't really identified strong varietal tolerance in the cucurbits yet, but in mentioning peppers, that is an important thing, that cucurbits and peppers are not rotated with each other because they're both hosts of this very damaging disease. Disposal of culls, so not spreading culls into a production field where you've run into problems, or upslope, having culls upslope from a production field. Again, you can get the movement in the soil water there. So thinking about how you want to manage those culls, either it be through deep burying, through application to non-vegetable land, or through composting of those culls, whatever you can do to reduce that source of inoculum. And then you can also improve your success through improved drainage and raised beds so that you never have wet feet on that crop or on the fruit sitting on the ground. Fungicides offer suppression at best. Even the best fungicides, and we don't have a good rotation of fungicides that we can call upon, but even the best ones we have are only suppression. If the disease is prevalent in the soil, the fungicides aren't going to stop that. And if you are using fungicide, then the timing is quite specific. You're looking at application at planting, and then probably through the drip lines if you want to have crown rot covered, or coverage of those new fruit to protect against fruit rot. And getting good coverage of cucurbit fruit through that canopy is very difficult, which is one of the reasons why we don't have great success with the fungicides to control this disease. So those are the wilt diseases. Next up, I'm going to be covering foliar diseases and fruit rots. That says root rots, it should say fruit rots.